Hey, good morning. It is time for lesson 4-5, direct variation. Before that, I got a joke for you. The parent says, "Hey, kid, how's your math homework going?" Child says, "Well, m is negative, so at least I'm on the downslope." That's a good one. Oh my gosh, that's hilarious. All right, well, we're going to start today with a special type of direct variation. Never mind that little message you just got. And it's called direct variation. Direct variation is a linear relationship that can be written in the form y equals kx. And what I want you to see right there, y equals kx looks a lot like y equals mx plus nothing. So you can make that assumption, yep, m and k are both slopes. But in the case of direct variation, our y-intercept is always 0. We always start at the origin with our line. Direct variation means as one goes up, the other goes up directly. So as x changes, y changes as that constant k defines. So one of the examples says, a recipe for paella calls for 1 cup of rice for every serving. So if we look at this relationship, 1 cup, 5 people, it says. So 2 cups, 10 servings, 3 cups, 15, etc. And we can quickly see that it is direct variation if we took servings is equal to what times rice. We can quickly see that that variable is 5. Take any serving, multiply it, any amount of rice, multiply it by 5, and that's how many servings or people you can feed. If we look at example 1, it says identifying direct variation from an equation. We're going to identify by looking at the equation. It gives us an example 1a. It says, here's our equation, y equals 4x. Well, we can go back and think, is that similar to y equals kx? And of course, it is. This direct variation equation is in this form, y equals kx, and we can locate that value k, which we call the constant of variation. It constantly varies by a factor of 4. So if we look at example 1b, we see this equation, negative 3x plus 5y equals 0. And of course what they want to do with this equation is see if they can get it into this form. So we start by solving for y. We're going to add 3x to both sides. And we're going to divide by 5 to isolate that y. And we see again y is equal to 3/5 x. Again, in that same exact form for direct variation. And this time we see that our constant of variation is a fraction, 3/5. Example 1, part C, gives us the equation 2x plus y equals 10. That should be our indicator right there. That's the giveaway, that constant value in our function. Pardon me, sorry. That value 10. If we were to solve this for y, subtracting 2x from both sides, we see that y is negative 2x plus a value 10. The equation does not represent direct variation because it cannot be written in this form, y equals kx plus 0. We do not have a 0 constant value. We have this value 10. So this is not direct variation. So I'd like you to do the check it out problems 1a through 1c. Check it out, 1a through 1c, and please come up and show me your solutions to those. Show me. So at the top of page 261, it says, what happens if you solve y equals kx for k? Well, let's go ahead and do that. We're going to solve for k. We can see that k is being multiplied by our independent variable x. So we're going to divide both sides by x, and k is equal to that ratio y divided by x. So in direct variation, the ratio y to x is equal to the constant of variation. Another way to identify a direct variation is to check whether y over x is the same for every ordered pair. So let's look at example 2. Example 2, we have a table. We're going to look at those values 1, 3, 5. This is a quick way of telling from the table whether we have direct variation. We just discovered in solving y equals kx for k that constant k every time needs to be the same. We're going to take these y values, 18 over 3 and 30 over 5, and we can see that those all simplify to the value 6, which is our k value. So from the table, evaluating, making sure that those ratios y to x are all the same, we can come up with our function y equals 6x. So go ahead and do the check it out problems 2a through 2c, and I want you to come show me those so I can eyeball them. Thank you. Example 3 wants us to write and solve direct variation equations, and it says the value of y varies directly with x. So what we know to begin with is that we have a function in the form y equals kx. It says y equals 6 when x equals 12. And we want to find y when x equals 27. Well, the first thing we need to do is come up with our function. So we're going to replace these values. When y is 6 and k is 12, we can quickly see, dividing both sides by 12, that k is the value 1/2. And writing that y equals 1/2 x, we can quickly evaluate for y when x is 27. Y is equal to 1/2 of 27. Y is equal to 13.5. Go ahead and do check it out number 3. Check it out 3. Show me your solution. And when you have been checked off for that, I'd like you to go ahead and start your assignment. That is starting on page 263. We're going to be doing 10 through 17 and 20 through 46. Catch you on the flip side.